Okay. Okay, look. So now, this is example 2. Look at that. Example 2. And example 2 is given this equation. So the first thing you should do is identification and what function belong to this family. Okay, in this case, I can see a square. This exponent indicate me, this belong to this function. This is
Yes,
the
square
basic,
function.
exactly, a square function. This is the basic, this is the mother in this family, okay? But the second thing that you try to understand is how many transformations and what kind of transformation we have. Well, remember, si you suppose que f of x belong to this family, que es a square, makes sense, right? Let me, Now, the first transformation according to the order of operation is the subtracting 5 inside the parentheses, like that. Okay? And this is classical horizontal shift. 5 unit to the right. Because I need to know by memory when it's negative to the right, when it's positive to the left. Okay. The second transformation is this, put a minus outside. That actually is minus x minus 5 squared. It's a reflection. It's a reflection. It's a reflection, but a reflection about x-axis. Because we have two kinds of reflection. No, be careful. We have that kind of reflection. This is f of x. It's different when you put a negative here or when you put a negative here. When you put a negative inside the parenthesis, it's reflection about the y-axis. And when you put a negative outside, it's reflection about the x-axis. Okay. And finally, you addition 3 outside. Okay, this is obviously a vertical shift, 3 unit up. Okay, this is the idea. So let's do it one by one, step by step. Well, I propose you doing the decimals. Okay, but this is the analysis. In decimals, let me try to share the screen for decimals now. Okay, you go, there you go. There's decimals. Here. Wait a second. You see this one? You see? You see? Yes or
Yes.
no? Okay. This is example 2. Boom. Well, but let's do it step by step. Boom, boom, boom. The first step is, this is the basic function, x squared, square function. The first transformation is minus 5 inside the parentheses. Boom. Look at the effect. The effect is vertical shift, 5 units to the right. Okay, point by point. Point by point. What is the second transformation? The second transformation is the minus outside, represent reflection about the x-axis. Boom, flip it. Look at that. There's the blue one. And finally, plus 3. Plus 3 is vertical shift, 3 units up. Boom. Okay, so my final answer obviously is the last one. No, is this parabola. No? after the tree transformation. Any question? Do you understand this or no? Sure? Do you see that?
Understand.
Excellent. This is easy. This is, do you see before in Algebra 1 in high school? Yes or no? No? In high school, you see in Algebra 1? Do you see that or no? Yes or no?
Yes, I was also taught that in Algebra 2.
Oh, in Algebra 2. Okay. Okay, super. Let's move on to the, I bring, carajo. I close everything. I'm crazy. I close the whiteboard application. I open it again. There you go. Okay, don't interrupt me. I don't care anything now. You pay attention. You are late, you pay attention. Okay, let me know if you see now whiteboard. Do you see
I see
whiteboard?
it.
Okay,
I
super.
see it.
Okay, let's move on to example 3. Example 3. Okay, example 3. Example 3 is easy also. Is f of x equal x minus 1 raised to the cubic power plus 7. This is the function que es given, ¿no? Entonces now, first step, identification at what family belong this function, and also how many and what kind of transformation we have inside the function. Okay, to answer the first question, what family belong this given function? Come on, tell me.
Cube function.
Cube function. Very well. Cube function. Very well. To answer what is the transformation you can see, remember in the order sequentially, step by step, because you need to respect the order of operations. What is the first transformation? This is f of x. Okay, suppose at the beginning is x cubed. I select that. But what's the first transformation? Okay, I can see according to the order of operation here. Here. When you plug it in, you ask by yourself, when you plug it in here, what number? What is the order of operation? When you subtract, 1. After you cube it, and finally you add in 7. So the order of operation is x minus 1. Okay, this is the order of operation. Of course, the cubic function is the same of the original, and this is a classical horizontal shift. Horizontal shift 3 units to the right. To the right because it's negative. Good. Now, the last transformation is plus 7. Plus 7, que es ya finally our original given function. Entonces, this is 7 unit. And this is vertical shift, ¿no? 7 unit up. You see that? Okay. Now, bueno, I open Desmos to see the idea. Let me try. Boom. Boom. Now you see Desmos, I suppose. Yes or no? Example 3. Example 3. Do you see decimals? Just doing step by step. Okay. The cubic function. Do you see decimals? Yes or no? Answer me. Yes or no? Hey.
Yes, Professor, I see them. Good morning.
Okay. Good
Not
morning.
yet.
You see the cubic function. Look at that bar. This is the cubic function. The first transformation was horizontal shift 1 unit to the right. Bam. In green color. I move everything point by point to the right. 1 unit. And finally, 7 up. Boom. Okay, this is my final answer. Boom, boom. 7 up. Okay. Entonces, ¿es easy o no? ¿Es easy o no? It's complicated.
Not complicated at all.
But I want to complicate a little bit now. I want to complicate a little bit now. Because in this example we were doing before, the transformation is clear. It's totally explicit. You see clear. And some example, by the way, is the most popular example. It's not clear. Sometimes it's confusing. Sometimes it's not explicit. The transformation. Let me see how I understand that. We have this classical example. Example 4. Example 4. Example 4. Example 4 is f of x equal square root 5 minus x. Okay, to answer the first question, what family belong this function is given? What family?
Square root.
Exactly, square root. To answer the question, how many transformations and what kind of transformation we have, this is a little bit complicated because I am not sure I see 1 5. This 5 is inside the parentheses because I can interpret the square root like a parenthesis, grouping symbol. Yeah, okay, I understand that. 5, but I don't know if it's to the right, to the left, if it's vertical shift, if it's horizontal shift. And also I see the minus in front of the x, que indicate always a reflection. Okay, so now to understand a little bit more clear in this classical example, que always you can see in the text. You move, you do something here inside. So I propose you factorization -1. Okay, actually, you say, Professor, but 5 have no negative. No, artificially, I factor out -1, so I have x minus 5. Let me verify si this is equivalent to the original or no. Bueno, -1, then x is -x, and -5 is +5. This is equivalent. However, this is more clear. This is more clear now to understand the transformation because, in my opinion, the first transformation that we are doing is reflection. Look, you change x for -x. Okay, this negative indicates reflection. Reflection, pero this reflection, wow, is reflection. Reflection about y axis. So my square root graphic look like that. Look, the original. This is a square root basic. Now after the reflection, I suppose this is the y-axis. This is my new one, square root -x. So I consider only this negative. After that, x minus 5 represent something like that. F is x minus 5 represent horizontal shift. 5 unit in this case is to the right because it's negative, no? And since to the right, my last transformation look like that. Look, something like that. That point original is 0.0 0.0, only reflection. I flip it up, boom, 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 like that. Now it's 5.0. Okay, 5.0, something like that. Is the reflection. But okay. This is a, intuition. However, I want to see clear, like the water, and Desmos. Okay, so now, okay, Desmos. Boom. Do you see Desmos? I suppose, right? This was the previous example. Now, example 4. Example 4, we have, look, square root. Hey. Step by step. Square root function. No. The square root function is the first. Boom. I put in red color. Now, reflection. Boom. This is reflection. Reflection about y-axis. Okay, and finally, -5. Boom. Is very horizontal. So horizontal shift, 5 units to the right. Just in case, to make sure that I'm doing well or not, I put the original, and the original put in blue color. There are perfect coincidence between the blue color and green color. It's the same. So basically, in this example, you see some new, and some new is not always the function gets given is ready to understand the transformation. So you need to manipulate a little bit algebra. Let's see after another more complicated example in which you, after the manipulation, so you see clear what is the transformation. Okay? Okay. Let's come back again to the whiteboard. Okay. I suppose you see whiteboard, right? Yes or no? Do you see whiteboard? Super.
Yes.
Super. David, you always support me, okay? When there are something, you have a strong voice. Yes. Or no? You help me see you say no. Okay, now, the last example. I promise in the review packet, we see more example, no? Suppose f of x, this is example number 5, no? Example number 5. Example number 5, f of x equal x squared minus 4x plus 5. Well. Question number 1. What family belong this function is given? What family? What is the original basic function? Okay, create this.
It's a square function.
Absolutely. You are right again. And a square root function. Okay, so now I don't see anything about transformation because negative 4x plus 5. What the hell? I don't understand. Okay, to understand more clear, you need to do some transformation. I propose you, for example, replace f of x for y. You know it's the same. Okay, after that, I complete the square. For example, x squared minus 4x plus 4. And remember the magic number to complete the square. And 5, well, I don't know. See, 5 stay here. Or you move to the other side, either way, no? In order to keep the equilibrium, you put one number here and you subtract the same number, or put it on the other side, either way. Okay, suppose remember the formula is b divided by 2 squared. In our example, b is 4. 4 divided by 2 is 2 squared 4. So we need 4 here, no 5, to complete the square. So now in order to doesn't affect my original product. You subtracting 4. And positive 4 and negative 4 together is 0. 0 is nothing. Is the null elements at 0. Now I am ready now to this trinomial factorization is x minus 2 squared plus something. Entonces 5, sorry, minus 4 is 1. Whoa, super clear the transformation after they completed the square. Number 1, guys, see is f of x minus 2, que es the classical horizontal shift 2 unit to the right, because it's negative. After f of x minus 2 plus 1 is a vertical shift 1 unit up. That's it. Okay, is it clear or no? Nobody saw at the beginning. Wow. But see, you complete the square, yes. In this case, useful, complete the square. Let's see now the decimals in this example. There you go. Boom. Let me share decimals. Okay, here. Excellent. This is decimal, right? You see? Example 5. Well, on example 5, well, this is the final answer. No. This is my basic function, okay, it's a square. Okay, the first transformation is, you know, horizontal shift to the right. Look at that. And finally is 1 unit up. Wow. Let me change the color. See, I change the color to the black color, for example. It's something like that. Okay, let me delete that and delete that. This is my final answer. Okay, is perfect coincident with the given information, is x squared minus 4x plus 5. Look, wow, using the same color. No, I want to change the color. I want to change to the blue, for example. And so you see that they are perfect coincidence between the black and the blue. It's the same. They are equivalent. The only thing that I did the transformation of the complete square to see much better. But it's equivalent. It's the same thing. Any question? How do you feel in that part? We need to practice more. That's the reason for that reason, you have to do the homework as always, you know, in Alex. Okay, any question, tutoring service, or email me any question. Okay. Let's come back again to the whiteboard. Whiteboard now. Okay. So now we're discussing another topic. Another topic is easy. It's a combinations of the function. Combination. You see the whiteboard of the function. Do you see the whiteboard or no? David?
Yes, I see it.
Okay. The combination of the function. Combination how? We're using the arithmetic operation, addition, subtraction, multiplication, and division, and composition is the last one to use. For example, the sum. Okay, the symbolic way to indicate this is using this notation, f plus g of x. Okay, by the way, this is equivalent to say f of x plus g of x. Super easy, just addition. This is a new notation. You need to be familiar. But the name is f plus g, but it's logical, no? The subtraction or the differences, difference is f minus g of x, is f of x minus g of x. Okay, okay, same thing. The product multiplication. The product is, well, f dot g, because it's time multiplication. X is multiplication, f of x times g of x. And the quotient or the division, the quotient. The quotient, the symbolic notation is f division g of x. To indicate that this is a combination of the function. This is f of x divided by g of x. Wow, this is super easy, straightforward. So what is the most complicated part, in my opinion? Is, well, okay, and the problem say, okay, we find the combination two functions. However, super important moment is state. Is domain. Because we study how you find the domain when you have equation of the only one function. However, how you find when you have two functions? Well, it's easy. Is and this is domain of f intersection domain of g. Okay, and addition, subtraction, and product is just you compute, you determine the domain of f, you determine the domain of g, and you see the common element. And the common element is the element that share both function and also is the domain for the combination. In this case, it's similar, except that we have one more restriction. It's domain of f intersection domain of g, and the classical condition, you know, intersection and f of x no zero, because it's impossible to be divided by g. Okay, let's see example. Let's see example, and immediately you understand much better this. Suppose example, only one example, but using everything, addition, subtraction, multiplication, and division, no? Okay, look. Suppose get given to function. Example. Is given to function. F of x is equal 1 over x plus 3, and g of x is another function, is equal x over x plus 2. And my question is, well, find what? Find everything. Find f plus g, comma, f minus g, comma, f times g, comma, and f divided by g. An important state is domain. Okay. By the way, let's do in the domain of f. Okay, f is that function. Remember the restriction. So the supposition, the domain always is the same. The domain, you suppose que is all real number, except the restriction. And the restriction, I repeat one more time. This is important. We have three kinds of restriction. 1, 2, 3. When you have division and between two things, the bottom part, not zero. When you have a square root, any expression, the expression inside must be non-negative. And we have the combination of both, okay, the square root and the bottom is positive. Keep in mind this. This is important information to analyze the domain when you have in your hand the equation. Okay, now it's obvious in our example apply this idea. Because the division, no? Is the division. So now domain is when the expression in the denominator gets q, in our example is x plus 3, and no 0. Therefore, x no negative 3. Okay, so the domain of this guy is Let me express it in Diana, is my laptop, I don't know. Okay, pay attention, this lecture. Domain is, you can represent like that. Domain is X value such that X not 3, no negative. This is one way to represent it using set builder notation. And domain of G is the same because it's the same idea, is one division. Entonces you take the denominator expression. I don't care numerator. No. P is not participating in the game of the domain. So plus 2, no 0. Therefore, X is no negative. So this is the domain of G. Is negative. And together, the intersection, domain of F intersection, domain of G, okay, by the way, should be the domain of this, and of this, except in this case, G and X no 0. But okay, it's valid for the at least the first three combination. Is the value of the X such that X no negative 3, comma, and X no negative 2. So basically, we have two holes. One hole and negative 3. So suppose, I try to see in the number line. Let me try. In the number line, this is my all real number line. Okay. Negative infinity, positive infinity. I discover we have two holes in my problem. One hole in negative 2 and one hole in negative 3. Okay, so we have a hole here. Wait, let me use blue color. One hole here and one hole here. Now my domain is all real number except this guy, is this restriction. Okay, therefore, so you want to represent in the test guide, always you represent using interval notation, not this notation. Is is domain of F intersection domain of G. Case this expression much better in the test and interval notation is from negative infinity, comma negative 3. So that is union negative 3, comma negative 2, union negative 2, comma infinity. Okay, this is the answer I want in the test. Always interval notation, never set builder notation. This is good. Sometimes it's useful, but this is the answer I want in this. Okay, and the recipe is okay. Wow, the rest is just the rest is just to find the expression of this function. Well, it's doing is F plus G and X is 1 over X plus 3 plus X over X plus 2. You can leave it at that. You can. Why not? Another two say no. I prefer. Okay, so do some algebra here. You condensing this and this in only one fraction. Why not? And you find the least common denominator is X plus 3 times X plus 2 is the least common denominator, LCD. So when you divide this by this is X plus 2 times 1 is, and here is X times X plus 3. I suppose you understand very well this algebra because it's elementary. Now let's do it like that. No. Let's continue a little bit. We continue how well you remove the parentheses and combine like terms, if it's possible. Entonces is X plus 3, X plus 2, x plus 2 plus x squared plus 3x. Actually, I think I'm doing is distribute the property and combine. And combine it and organize is x squared plus 4 because 1, x, and 3 together is 4 plus 2. Okay, this is what is my beautiful final answer. Well, my beautiful final answer is x plus 3, x plus 2, x squared plus 4x. Boom. Okay, by the way, guys, this is equivalent to this. Okay, to this. Okay, that part, if you don't want, you don't need to do. And, well, what is the advantage of this? This is easy, I finished. However, you have two fractions separate. How you know algebra to condensing the fraction in only one compact fraction. Can have only one numerator and denominator, only one, no two separate. Let's do it f minus g. It's exactly the same. It's 1 over x plus 3 minus x over x plus 2. If you want complete optional condensing, you put the least common denominator. This is x plus 2 again, minus, in this case, minus x times x plus 3. Apply one more time, distribute the property, and combine later. Okay, and we have that expression. Okay, it's x plus 2 minus x squared minus 3x. Okay, now we have plus. We have minus x squared, organize and descend the order of the degree, positive 1 and negative 3 and negative 2x. Plot. It's a beautiful. Okay, this is expression, and don't forget that the domain is this. For this and this. Okay, no. Multiplication. Multiplication is easy. It's easier. Why? Because when you multiply two fractions, you don't need to find least common denominator. No. There's only one x plus 3 times x over x plus 2. Wow, easy. You multiply top, bottom. 1 times x is x. And in the bottom, we have x plus 3 times x plus 2. End the story. That's it. We finish. We finish because multiplication not necessarily find the LCD. It's only multiply numerator, and denominator. Division. Well, division is F division G. It is, well, in this case, you divide. Suppose you divide 1 over x plus 3 over x plus 2. And remember how you divide two fractions. It's a complex fraction. You copy exactly the same denominator and flip it, the denominator or the fraction in the bottom. Okay, so again, multiplication, this and this. This says x plus 2 times 1 stays the same over x plus 3, so x times x plus 3. This is the expression good, but the domain, remember, sometimes you need to fix it a little bit according to this idea, because in the division is picky, and the division maybe appears in new restrictions. So the new restriction that you can see here is, look, is when the denominator is 0, and denominator 0 is x plus 3, not 0. It's obvious that x not 0 and x no negative 3. And negative 3 is a coincident with the same analysis we were doing before. So in our domain, we have here, we have two holes. The hole is a -3 and the hole is a -2. But in the division appear new hole and 0. Look at that. Okay, so we have a hole here and 0. The expression for the domain is a little bit more complicated. The domain is from -infinity, comma -3, union -3, comma -2, union 1, 2, -2, comma 0, union 0, comma infinity. Okay, we have a new hole in the division. Be careful. Therefore, now we have 3 restrictions. In addition, subtraction, multiplication, no, we have only 2 restrictions. Make sense or no? Super clear, in my opinion. Opinion, come on. Do you understand? In the test, you see 1, 2, and 3 questions about this. Different example, different expression, but it's the same. It's the same concept, right? Do you understand very well or no? No? Confusing? Tell me. Everything clear or no? Domain, combination, functions. And that's it? No. No. We have another kind of combination.
It's all clear.
It's clear, I suppose, yes. Another kind of combination is a composition. Composition, it's important, extremely important. Composition, function, or function composition, either way, you can call composition. Composition, function, okay? What's the idea behind composition function? And the idea is, look, we have two functions also. The classical f of x and g of x. And we have put a combination both, but in a different way, using composition idea. Boom, 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 composition. Composition is important, the order. What is the first function that you consider? What is the second function you consider? Suppose that the first one is g. This is the first. And it's the second. After we are doing in opposite order, but no, I need to try at least one. So the composition is, you suppose the second function bracket, the first function parenthesis, like that. So basically, the idea behind composition is you have two functions. And the function, you know, in my mind, I can imagine it like a box. We have element of the domain, get inside the first function, can I define get g. In this example, the first function can plug in sg, okay? And the result, okay, guess y, is the x for the second function gets f. And finally, we get the final y, get the y, total y in this order. Okay. The symbolic way to indicate this is f composition g. And the composition look like a 0, but no 0, it's a small circle indicate composition. And it's extremely important, extremely important the order. So never, no, but frequently, 99% of the time, this is completely different to F composition G in that order. Okay, because it's completely different idea. Look, in this case, when you define the first function is F and the second function is G, when you plug in F first, the X value, and the Y value you obtain, you plug in like an X in the second function. And this result never, no. Frequently, often, 99% of the time is not the same. Okay? This is the idea behind composition. Now, let's see example to understand more clear. For example, you have two functions. case, x squared plus x plus 1. Semicolon, and you have another function g. Is 2x plus 3. On day one, can you find the expression of the F composition G? And this order. So when this order is given, you need to understand that the first function, okay, wait, let me complete the symbolic way. Of X. You need to understand that G is the first one, okay? Because it's the letter G is closer to the X, and X represents the domain, element of the domain function. Therefore, the interpretation of this idea is que G, que is the first function, is this. Plugging in, completed here into the X of the F. Okay, so you write something like that. Look, 2x plus 3 square. This is this part plus 2x plus 3 plus 1. Do you understand the thing I am doing? Do you understand or no? Confusing? Clear? Do you understand?
It's clear.
It's clear. I leave it like that. No.
I get it.
Yeah, super. Now, this is the answer. However, I need to manipulate a little bit in order to express one more, you know, beautiful expression. Huh? You foil this one now. You foil 2x plus 3 times 2x plus 3. You foil, this is 4x squared plus 6x again plus 9 plus 2x plus 3 plus 1. Okay, just copy that part. This part is that part. When I do combine like term, it's 4x squared. We have 6 and 6 is 12, and 12 plus 2 is 14. 14x plus 10. We go from 10, 9 and 1. And this is my expression of the composition. Super clear? But wait. It's 9 plus 3 plus 1. I forgot the 3. Yes or no? Entonces es 14. Es 13, sorry. 13. This number is not 10. It's 13 because I forgot the 3, additional 3. When you combine 9 plus 3 is 12 plus 1 is 13. Boom. Okay, suppose in different order. Suppose that the problem say, well, no, wait. I want no like that. No, this is I want G composition F. Evaluate X. Well, in this case, when you see the problem, you understand it's completely different because the first function is close to X is F. This is completely different idea. You plugging in this function into the green one here in the X. You replace. So now it's easier, in my opinion. No, it's 2 parenthesis x squared plus x plus 1 plus 3. Do you understand the thing I am doing? Do you understand or no? Sure? And do you leave it like that or no? There are no reason to have this parenthesis. So it's 2x squared plus 2x plus 1 plus 2, sorry, plus 3. The final answer is 2x squared plus 2x plus 5. And when you compare this expression, and this expression is completely different. It's the most common it happens. So in general, the composition is not commutative. That means que in general f composition g of x no equal g composition f of x. I want to show you now in the chapter 4 there are some special case in which yes, etc. But this is a special. The most common que happen is no equal. Okay? So I propose you now go over again at the beginning and doing the review. At least today, the first part of the review. I don't cover everything 100%, but in the review you can see the rest. So there's a small topic, it's easy to understand, and in the review you see clear. Let me try. Let me try. Let me try. There you go. Okay. Okay. Boom. Do you see the whiteboard? Do you see? Do you see or no?
Yes, I see it.
Okay, super.
I see it.
Okay, look at that.
I think
Okay.
everybody else is sleeping except for Jasmine and myself.
Say again.
I think everyone except for Jasmine and myself went to sleep.
You're right
Okay.
about that, Debbie.
Okay, guys. So the first question, number 1 and number 2, is super easy. Is determine the interval over the function is decreasing, increasing, and constant. What is that? What is increasing, decreasing, and constant? Okay, suppose okay, we have a function. I want to do my skill using drawing something, and you have the axis x and y. Okay, and we have something like that. It look like, I don't know, a parabola, open down. So I try to do this sketch. And the point is given is this point is 4,0, -4 because it's symmetric. And this point is 0,7. And they want to understand, see the function is decreasing, increasing, or constant. What is the idea behind that? Well, you move in the domain from left to right. So this is my domain. My domain from -infinity to +infinity. The motion is in this direction, from left to right, left to right. Entonces, you suppose que my curve look like a roller coaster. And this is the roller coaster car. And this car is moving from left to right, always, never back. Entonces, when you see the high of the roller coaster increasing, this is increasing function. So the roller coaster in this interval, okay, by the way, is from -infinity to 1. Okay, this is -infinity to 1, not to 0, sorry, 0. The car increasing the highs. There's an increasing function. So in this interval, okay, is from -infinity, 0, no include 0. Let me explain why don't include 0. The function is increasing. Do you understand the idea is yes or no? Because the roller coaster is going up. So the y value increases. Now, in the second part of the parabola, the roller coaster after the 0 is going down. Therefore, from 0 to +infinity, the function is decreasing. And that's it. And never is constant. Never is constant. Because to be constant es que en some interval the curve is flat, and never is flat. It's increasing and after decreasing. And what is the reason I do not include zero increasing? The reason is clear. Because zero is the transition point. Que the function is increasing, boom, stop, not increasing anymore. No. It's going down. And it's a local, the name, technical name is local maximum. Local maximum. It's the technical name. Okay, maybe you have local maximum or maybe you have local minimum. Okay. And this is you see in detail in calculus. The student can need to take calculus. What is the idea behind local maximum, local minimum? But you know, it's the transition point in which my function stop increasing, not increasing anymore, to increase. One super important detail. When I forgot to say something, I forgot to say that this interval is the blue interval is the interval in which the function is decreasing. The blue was decreasing, red was increasing. Do you see that? I never got in this example. One super important detail to say. Well, I give you a points using X and Y, but I give you to confuse you. No, you don't care that. When you express it, the interval increasing, decreasing, always we use an X value. Never Y value. This 7, the students say, no, increasing from negative infinity, professor, to 7. No, because 7 is a Y value, and this Y value you forgot. Okay? And the only important value, this is not important. The only important value is 0, because 0 is the transition. It's the X value, domain, X value in which change the behavior. So my function increasing, stop, decreasing. And that's it. Clear or confusing? Clear or confusing?
It's clear.
Super easy. It's straightforward. Let's see the second example in the review. You see it's also clear. I promise in the test, you see question 1 is exactly the same. Similar, no? However, some students fail that question. Why? Because put the Y value. No Y value. No Y value. It's X value, domain value. Okay, I try to do the second one. XY. We have 2 points here, get negative 0.5 and positive 0.5. And our curve look like that. Okay, let me see here and here. Okay, let me use in red color. This is this, and this. I did my best. This is a smooth curve. Never you have a sharper point. Something like that. Wow, what is this noise? What is this noise? Come on, David. Putting off.
Oh, I'm sorry. My air conditioner makes a lot of noise. I forgot to turn it off. I apologize.
Okay. Now, remember, our roller coaster is coming from left to right in that direction. Never go back in that direction. Our roller coaster travel on the curve. Boom. Like that. Boom. Like that. Boom. Like that. Okay, here I can see clear like water. Okay, from negative infinity to 0.5, my roller coaster is going down. Entonces now it's decreasing the behavior. Decreasing is from negative infinity, comma, negative 0.5. Never include the transition point because in this case, this point is local minimum. But I don't care that. This is decreasing, but it's decreasing also here. Look at that. From 0.5 positive to infinity. 0.5 to infinity. It's also decreasing because the roller coaster is going down here, down, 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 down. It's going down, downward, down and down. Entonces, to complete the idea for the decreasing is union 0.5 positive, comma, infinity positive. This is decreasing. This is decreasing. Super. And what about increasing? Well, it's when the roller coaster is going up. Because this case is from, well, from negative 0.5, no parenthesis, no, comma, positive 0.5. This is the interval is increasing. My function is increasing my function. Okay. And you highlight in blue. Why not? And this interval is completely open. The endpoint is not included because this point is transition point. By the way, this is local max, and this is local mean, minimum. All right, and don't include it in the interval case increasing. This is extra. So basically, in the test, I ask you, what is the interval in which the function is increasing or decreasing? Remember, no consideration ever the y value. In this case, happy. In this case, there are no information about the y value at that point and that point. However, in the test, yes. In the test, I promise to confuse you, I put x and y, and you ignore totally the y value. So the interval is the interval under the consideration is domain value, and domain is x value, always. Okay, you understand? Okay, we are doing number 1 and number 2 questions. Any question? Too fast? Everything is okay? Okay, or no? You are totally lost? Okay, Angelica. Okay, let's move on to the piecewise function. Because in the test, I promise, okay, put the piecewise function, suppose f of x, I want to copy again, is equal, we have 3 pieces, minus 3x plus 2, if x is less than negative 2. Remember, piecewise function is a function that you define using different p's, and the p's have conditional. This if is the conditional. See the value in the domain that you pick belong to this condition. You select the corresponding expression. Otherwise, no. X greater than or equal to. Okay, entonces day 1 que yo evalué en negative 2. Day 1 que yo evalué en negative 3. Day 1 que yo evalué en 0. Bueno, okay. Let's do it. Wait. Second. Let's do it in 0. Let's do it in 5. Let's do it in positive 3. Let's do it in negative 4. Okay. So now remember, the process is, let me start x equal negative 2. X equal negative 2, what condition below? Number 1, number 2, or number 3? Okay, so you don't see clear, we can do we can do the geometric interpretation of this using the number line. Because you see clear, it's okay, not necessarily the geometric interpretation. Look, this is the Orion number line. Negative infinity, positive infinity. We have transition point. Transition point in this case is -2, 1, 0 in the middle. -1, -2 is here. Transition. Positive 3, 1, 2, and 3. Another transition. We have 3 intervals. This interval, maybe using different color. This interval, and this interval. And now the association is in the yellow, in the yellow interval, the function is equal 4. And the function is just 4. It's a constant function. And the green one, and the green one, and the green one, and the green one, the function is, well, this is x squared plus 1 function. And the blue interval, well, in the blue interval, the function is linear, it's -3x plus 2. Be honest with you will be capable to see the interval without the geometry representation, or you need the geometry representation. It's useful or not? Because if it's not useful, I can erase, and that's it, right? Tell me, answer me. Not necessarily the geometry, not necessarily geometric representation.
I find it useful when I do the examples.
Because my question was, do you need, so to understand the piecewise function, you need to represent geometrically or no? Or no?
When I do the math, I always make the representation for myself.
How? But in another way, David, in another way, by yourself, in another way, or in this way? Okay, put in the board.
No, the y I do up and down.
Well, another opinion, not necessarily David. What do you think? Is useful this idea or no? No. No. No, because, well, okay, no, I don't know. It's up to you, no? Okay, entonces -2. Okay, let's do it -2. -2 now, -2. -2, here, over there. Bam, 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 bam. What interval lie -2? In the blue, in the green, or in the yellow? Come on. Tell me to understand this complicated thing.
It'll be x squared plus 1.
Absolutely. How do you know, Yasmin? How do you know?
Because x equals -2.
Exactly. The key idea is that equal sign. That equal sign, that equal sign, that equal sign. Indicate me to add specific, exactly -2, you select the green. Okay. Basically, so you need to understand a little bit more clear. This is a bracket here. This is a parenthesis here. No include -2. And 3 is bracket in yellow, no? In yellow bracket, yellow bracket, yellow bracket. And this parenthesis is green. More clear. And the endpoint, you know, que es important, no? It's always the question. Entonces, you evaluate, so Yasmin say que you select the expression x squared plus 1 because -2, I know very well que belong to the green interval. I'm plugging in -2 at -2. -2 squared is +4 plus 1 is 5. Boom, final answer. Okay, let's do it -3 now. -3 belong to the what interval? Belong to the blue, belong to the green, belong to the yellow.
It belongs in blue.
Blue, of course. Entonces, now, si belong to the blue, the selection is the expression -3 plus 2. I'm plugging in x equal -3. Entonces, -3, be careful with the sign. -3 times -3 plus 2, negative, negative, positive, positive 9, plus 2 is 11. Boom. 0. 0 is clear. Belong to the blue, belong to the green, belong to the yellow. Another participation. Not only Yasmin. Come on, guys. I have excellent students here. I know. Angelica is super good. Juan Gomez is super good student. Green. I mean, who are you? Brian. Brian said que green. Let me see. Absolutely. You're right, Brian. Is green. Entonces, you select, si es green, you select the expression again, x squared plus 1. And you evaluate at 0. 0 squared is 0 plus 1 is 1. Final answer is 1. In this case, 5. 5 belong to the blue, to the green, or to the yellow. Another participation, come on.
4.
Come on. 4.
It belongs to yellow.
Belong to yellow, yeah. And if you belong to yellow, the function is 4, and 4 is completely independent of, Edward. Super. Excellent. I appreciate so much, guys. And 4, that's it. Because this expression do not depending on x, and this 5 actually don't participate in the game. What about 3? This one. 3 belong to the yellow again. Juan Gomez. Entonces, si belong to the yellow is 4 again. 3 and 4 and 5 and 20, 104. And -4, and -4. -4 belong to the what? Blue, excellent. Brian Duran. The Brian Duran say que es blue. Si es blue, entonces ahí select the expression -3x plus 2 and evaluate at x equal -4. -4. Be careful with the sign. -3 times -4 plus 2 is a positive 12 plus 2, 14. Boom, final answer. End the story. We are the best and Miami the coach. No problem. We have in the test number 2. I know I don't need to call 911. Emergency. No. In this class. In other class, yes. But in this class, no. Any question? Any question? Any question? No problema. May I erase the board or no? You copy? You copy in your notebook? Or you watching the video after? And you copy after? What is the best way to understand the lecture? You copy in the same time that the professor is playing, or I copy when I'm watching the video, or you don't prefer watching the video because I am present in any lecture. Okay. Depende, no? Depende. There are different formulas. Okay, let's do a number 4 example. Number 4 is similar, very, very similar. Is do the graph of the piecewise function. I promise in the test, you see one problem similar to this. Of course, different function, different number, and one problem different. So the same of this. In which not necessarily evaluate. No. You do the graph, only the graph. If x is less than 1, and 4 is a constant again, if x is greater than or equal. Entonces now the do the graph is not completely different, but it's different to the evaluation. Evaluation is easier. You determine the interval, you selection the function, and that's it. I'm plugging in the graph. No, in the graph, the procedure is a little bit different. You take piece by piece. I take the first piece. Is this. Okay. And I copy here separately y equal minus 3 plus x. Because you know that this is y, no? F of x is y. Now I realize, wow, it's a linear function because degree 1. Entonces, to see much better, in my opinion, you interchange this, x minus 3. In my mind, I organize like that. This is mx plus b. Okay, it's a linear. Yeah, I saw okay, slow and 1 because the invisible coefficient here is 1 and b is negative 3. And b represent the y in a set. Y in a set negative 3, negative 1, negative 2, negative 3. At this point is the y in a set of this line. And the slope 1. And the slope is 1. Therefore, I apply the idea for the run and rise up to the positive and 1 point here. Rise and roll. In this case, 1, 1. Because the slope is 1. And now, using my rule, I do the graph, 45 degrees. Because the slope is 1, 45 degrees. And doing this line. This line is, you know, temporary. It's auxiliary contraction. Because I know that one interval, my piecewise function, is coincidence with this idea, but not 100%. And the second piece, oh, it's easy. The second piece is easy. The second piece is just 4. And 4 is a constant function. So I copy y equal 4 is the horizontal line. No slope, horizontal. Horizontal is 0 degree. So the connection server broke it down. In your computer, but my computer is strong. Everyone have connection? You lost connection or not? No? This is the disadvantage of the online class. You have a good internet, you need to have a good computer, no? No good computer, no good internet, no good connection. Y equal 4, y equal 4, horizontal, 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 how? 0 degree. How is 0 degree? Well, 0 degree like that. 0 degree. Passing through 1, 2, 3, and 4. Boom, here, over there. This is my second piece. So basically, the thing we're doing so far is do the graph of this and this separately. Like it don't belong to the one mathematical object, is the piecewise function. Now, I saw that the transition point is in 1. Look. 1 here and 1 here. Transition is in 1. Therefore, to make clear this idea, I am doing one vertical line. Vertical line is 90 degrees. Passing through 1. Because this is the line that split the plane in 2 semi-planes. To the left and to the right. And to the left and to the right, maybe in 1 here, over there. I prefer to the transition point using blue color. Look. And dotted line. Boom, 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 and 1. I know that something happened before 1 and something different happened after the 1. This is before, no? Before travel for the line and after travel for the constant. So now, for example, my graph look like that. Look. Stop here. Some students don't understand very well when you stop. You stop in the transition. Some students, I don't know why, doing so far. This is arrow. And stop here. No. Why? This is a Y and a Z. You stop in the transition. The transition change to another curve. Because after a constant function like that. Extremely important. This point and this point. And you need to specification close or open. How do you know what is closed? How do you know what is open? Equal sign indicate me this. This equal sign indicate is here is closed and it's no, it's open. Because I don't see any equal sign. No. Open. Close. Done. And the rest, they are completely optional. If you want, you erase that part. That part. And the transition, if you want, you erase. If you want, you don't erase, I don't care. I understand very well. I'll make it stay here. Boom. Much better make it stay. Any question? Any question? Any question? Please, why function graph? Any question? Any question? Any question? No? Come on. Everyone follow me? It's too easy that part. Let me investigate. Okay, Angelica, everything okay? And Lang, everything okay? Yes. Okay. Roberto Alcalá?
Yes.
Okay. Okay, super. We are the best. Okay, let's move on to number 5 question. Number 5 question is again graphic. This is the chapter for the too many graphs. Too many graphs in this chapter. Okay, super. I don't erase this one. Okay, what's the idea in number 5? Well, the idea in number 5 is we have a function is given minus x squared plus 4. And also find the y in a set. And also find the x in a set. Now it's important to the graph. In my opinion, the fantastic tools using for doing the graph is using transformation. No? Immediately, I realize that this function belongs to the family of the square function. But we have 2 transformations. Transformation number 1 is reflection. Okay, so in my mind, working like that. This is the basic. Quickly, roughly sketch. This is the x squared parabola. Now this first transformation is minus x squared. It's reflection. Look. Plus 4 is vertical shift 4 unit up. So therefore, after the last transformation is minus x squared plus 4. I suppose que es something like that. Entonces, this point, que es 0,0, is a good reference to understand que my last graph, the point is 0,4. And 0,4 is obvious que is the y in a set. 1, 2, 3, 4 here. 0,4. Okay. I start doing the graph, not yet. I use transformation, but I have in my hand at least the y. And this is a parabola. And this parabola, I know, open down, like that, boom, boom, open down. Well, so what is the formula, professor? Okay, what formula? I don't remember very well. What is the formula we need to use for finding the x in a set and the y in a set? Okay, the formula is y in a set is the function evaluation. This is the formula. And the x in a set is the function equal to 0. This is the only mnemonic device that you need to remember in order to find the formulas for finding a y and x in a set. Well, actually, I did that. I did that part. The y in a set is plugging in zeros, 0 squared, 0, 0 plus 4, 4. I did that. And the y is x in a set, no. The x in a set, you take the function, okay, it's minus x squared plus 4, and you enforce it to be equal to 0. Look, that part, equal to 0. But this is easy for us. This is a quadratic equation. So for solving the quadratic equation, well, let's do it. You, for example, moving 4 to the other side, divided by -1 both sides. Now we have x squared equal 4. Apply square root both sides because it's the easy quadratic equation. It's the equation that I am using the square root method because b is 0. So x is equal plus or minus. Actually, plus or minus 2. Because the square root 4 is 2. And don't forget plus or minus. Okay, super. Entonces this is 2, 2,0 is our first x in a set, and -2,0 is our second. And make sense because I know that our parabola is up and down. Okay. Using my common sense and my imagination, I suppose that my graph look like that. If you want, guys, you put in decimals and make a copy for me. Okay. I explained before how we make a copy. So when you do something in decimals, either way, guys, using paper, I understand. Using decimals, I understand. Using both, much better, because you confirm it, the thing we're doing. Suppose I open decimals. Okay, let me try one more time. Suppose I open decimals, yeah, I do the graph. Okay, by the way, the graph, well, okay. Let me see if you see decimals or not. Do you see decimals? Do you see? Okay. So now, the thing I want to explain now is, suppose that this is my graph. Okay, actually, it's not. You want to export this graph to copy and paste in my test. When one document, you click here. Look, and you print here if you want a piece of paper, or you export. Look at that, and you download in the format for like a picture. And this is medium, hard, bold, either way, the way that you prefer. And you change here the grill, for example, big one. Wow, I like that. The way that you prefer, using your common sense and imagination. Okay, this is one possibility to do in the test using this one. The equation. Everyone follow me? Okay, super. No problema. No problema. Okay, let's move on to the question 6. Okay, I want to erase the board totally. I want to bring another page for the review. Bam. Bam. Okay, there you go. Do you see? Okay. Number 6. Number 6 is a confusing question. Do the graph of this function. I want to call G is square root negative x plus 2. Remember, this is special. This is confusing. This is not clear. Why not clear? When you see a square root and inside you have negative something, plus something, so you don't know exactly what is the order. Si es negative first, si es reflection or es translation, in what direction is the translation, or shift, si es horizontal, es vertical, I am lost. However, si hay modification a little bit our expression, you factor out -1 outside this -1. Professor, pero 2 is positive. How can factor out common factor -1? I enforce this. This is x minus 2. Boom. Negative and positive and negative. Negative and negative positive. And now you see more clear. And now you see more clear. And now you see more clear. Okay, our transformation is reflection first. Reflection first, because of this negative. Okay, what is the idea? The idea is these belong to the family of the square root function. The square root function, I know, they look like that. The first thing I saw is one negative inside the radical. So if you understand this idea, look, this is minus x. This is square root minus x. This is reflection, but reflection about the y-axis. Now, the next transformation I can see is plus 2. And plus 2, no, minus 2 is the horizontal shift 2 unit. After that, 2 unit to the right. So now the last transformation is something like that. It's a 2. Okay, because basically at that point is 0. When you have minus 2 after this transformation, you move to the right. Okay, so our graph look like that, 2. But I have no idea. I know they open in this direction, but I have no idea exactly what is the y in the set. I know what is the x in the set. Okay, suppose look at that. Suppose I need to find the y in the set. It's also a question, no? In the test, no. No, but no, I included that. Okay, it's important. And the test, yes, I promise in the test, I guarantee you see, find the y in the set and find the x in the set. Remember the formula, it's g and 0, evaluar en 0. Entonces, g and 0 is square root minus 0 plus 2. 0 have no sign, 0 is 0, is radical 2. And radical 2, when you put in the calculator, because radical 2 is irrational number, this is approximately 1.41. So 1.41 represents 41 here. It's our y-intercept. Well, okay. Entonces my graph like that. I suppose. Okay. And what about the x-intercept? Well, x-intercept I did before. Is g of x equal to 0. Who is g of x? G of x is square root minus x plus 2 equal to 0. Basically, the only thing you should do is solve this radical equation. But it's super extremely easy because when you square both sides, it's minus x plus 2 without radical equals 0. Entonces, minus x equal minus 2, x equal 2. Boom, exactly we expect. This point is 2,0. This is the x-intercept. And this point is 0,1.41. It's a y-intercept. And our graph look like that. Any question? Any question? Everything is okay? Strong? Okay. Entonces, I recommend stop for today because we have time. Number 1. Number 2, next problem is a little bit complicated. So now So far as stop. Now I am in a few minutes. I will post the video for this lecture. Okay, guys.